Morning, everyone. No Booth Dog today, just Mr. Boothman. I'm sure you've seen by now the news that our school year has been canceled, in the sense that we won't be back in the classroom through the end of the year. We will continue through the end of the year in this manner. I really just wanted to reach out about that. I know I'm going through a lot of emotions right now regarding that, and especially all of my seniors. I can't imagine. Um, just know that you're not going through this alone. Okay, our whole society is being upended by this, and we are here for you, no matter what you're feeling or what you're going through. Um, I don't have any easy answers. I don't have anything I can say that will magically fix this or make you feel any better about it. It's hard. It's really unfortunate, and I know many of you understand the severity of the situation and why we have to do this, but it doesn't make it any easier. Just continue to push yourself here through to the end. I have said before, I've said quite a bit actually throughout the year, that one of the things I love about when you all complain about how hard my classes are is, by design, I need you to experience that struggle and that challenge, because I know I personally didn't experience that challenge until college, when I didn't have a very good support system yet. I didn't know how to persevere through something that was so difficult for me because I'd never had to. I don't like this situation any more than you, but crises and challenges like these give us the opportunity to see who we are. I jokingly ask some of you when you complain about how hard a test is, are you the kind of person who gives up? Are you the kind of person who just, shuts down? Is that what you're going to do in your life when you encounter a hard situation? Here's a hard situation. Are you going to push through to the end of this with the same tenacity and passion that you had before? Or are you going to give up? I can't answer that question for you, but my hope is that each and every one of you answers that question in an authentic, reasonable way. I'm here if you need anything. I don't like not being able to see you guys, but we'll get through this together. Stay safe. Let's start our lesson. Good morning, happy Tuesday. Thank you for getting through Unit 7, taking that exam. I'll have those graded as soon as possible. We have 2 units left, and luckily both of those units are pretty short. Each one should only take us a couple of weeks or so, just like Unit 7 did. Unit 8, we can see looking at this list here, Unit 8 is all about sequences and series. Now, every single one of you has seen sequences and series. You've studied it to some extent in the past. Definitely Algebra 1, maybe a little in Algebra 2. So we're going to kind of review that and take it a little step further. Those of you going on to Calculus BC next year, or anyone who goes on to take Calc 2 or higher in college, you will absolutely see sequences and series. It is a huge part of those courses, so pay extra attention if that's you. Announcements for the day. You'll be asked to answer some basic questions about today's lesson for your exit ticket. Still due by midnight tonight, but basic things just to see if you're watching this, if you're paying attention. Okay. The Unit 8 guide notes, both blank copies as well as my answer key and all of the independent practices for this unit are posted to Google Classroom, so make sure you pull those up as you need them. All right, let's get started. So, Unit 8, sequences and series. There are only 3 learning targets here. Section 8.1 is arithmetic and geometric sequences. Okay, so we'll talk about what those mean. Let's start by just defining what a sequence is. Okay, so a sequence, let's read the formal math definition first. A sequence is a function whose domain is the set of natural numbers. The values of f1, f2, f3, and so on are called the terms of the sequence. Basically, a sequence is an ordered list of numbers. So if we have some function, f of x, then as we plug in the natural numbers, that is the positive whole numbers, whatever those outputs are, form this list of numbers. Okay, and we do order them. So f1 goes first, and then f2, and then f of 3, and so on. Okay. Now normally, it relates to functions. These are functions, but normally we don't usually write it as f of x. Instead, we typically write our terms of a sequence with the variable a, and to describe which a we're talking about, whether it's f of 1 or f of 4, we use what's called subscript notation. So superscript, or an exponent, that of course goes above the number, off in this corner. Subscript means below the number. Okay, so a1, a2, a3, a4, and so on. Okay. Subscript notation, what this is just allowing us to label these numbers. So it's not an exponent, it's not like we're multiplying or doing anything with it. It's just telling us which position in our list this particular number has. So if we're talking about some random, some arbitrary term in our sequence, that would be the nth term. Okay, so f of n, somewhere over here. We don't know what n is. We just call that in general a n. The nth term. Here's an example of a sequence. So obviously, this is the sequence of even numbers. But to be more accurate, suppose I ask you, what's the 100th term of this sequence? Looking at it, I mean, we could keep writing this out. It's clear that it's just 2, 4, 6, 8, 10, 12, 14, 16. We could write this out all the way to the 100th term, but that would take a really long time, way more trouble than it's worth. And besides, what if then I ask you, what's the 224th term? Again, it's too much work to have to write out the entire sequence. Instead, if we can find some expression for the general function that's giving this sequence for the nth term of this sequence, it would be pretty easy to just plug in whatever number we want. So we have our input, that is the number in the sequence, the number in the list that we have, and then it would give us back whatever our output is for that particular term. Okay, so we want this procedure for finding this arbitrary term of the sequence. Okay. To do this, we need what's known as the formula for the nth term of the sequence. We want an. Remember, this is the same thing as f of n. Okay, sometimes we also call this a of n. Just to remind us that we're just talking about a function. Okay, but for this particular function, for this special function, our input is the number of the term in our list. So we want this expression here. Okay. So how can we come up with this general formula that would give us whatever our term is? Well, when our term is 1, so when n equals 1, our term is 2. When n equals 2, our term is 4. When n equals 3, our term is 6, and so on. So what are we doing with this term number? We're multiplying it by 2. So we have our term number, which is n, and we're multiplying it by 2. This formula right here should give us any term in this list, any term in this sequence. So what's the 5th term of the sequence? Well, that would be a5. Plugging in 5 for n, we would get 2 times 5, which is 10. And in fact, that is the 5th term. Okay. So we can always check. We can make sure that this formula works. Now, if I ask you, what's the 211th term in this sequence, you don't have to write everything out. Instead, we're plugging in 211 for n. And we should get 422. Just like that. So, just to recap, a sequence is a list of numbers. It's just a function. So this nth term formula is simply a function where our input is the number of the term in our list, and the output is what that actual term's value is. Okay. So looking at example 1. Find the first 3 terms and the 100th term of the sequences defined by the following. So they're giving us different nth term formulas, and they're asking us to find the first 3 terms and the 100th term. So for the first formula, an, or a sub n, we say it both ways, equals 2n minus 1. Okay. We want the first 3 terms, so that's going to be a1, a2, and a3. And the 100th term, which is a100. So these are values of n. So we're taking this, we're plugging it in for n in this function. It's just a function. We have 2 times 1 minus 1 is 1. 2 times 2 minus 1 is 3. 2 times 3 minus 1 is 5. 2 times 100 minus 1 is 199. So what is this the sequence of? This was our sequence of odd numbers. So the sequence of even numbers was just 2n. If we want our list of odd numbers, it would be 2n minus 1. Okay. I would like you, as your practice, to go through B and C. So feel free to pause the video here, work through those problems. I'll write out the answers here. All right, so we have 1/2, 4/3, 9/4, and 10,000 over 101. And then for part C, we have -1/2. Positive 1/4, -1/8, and then I didn't bother raising this 2 to the 100th power. I just left it as 1 over 2 to the 100th power. It's going to be an enormous number. Okay, so if you have any questions, bring those to the Google Meet. Now, that was nice if we're given the nth term formula, but what happens if we're given a sequence? If we're given our list of numbers, and we want to figure out the nth term. It's kind of like what we did with that sequence of even numbers there. We went backwards and we said, how is the term's number defining what the term value is? Well, that's exactly what example 2 is asking us. Find the nth term, in other words, find the formula of the following sequences. We want the function this time. So we have this list, 1/2, 3/4, 5/6, 7/8, and so on. Okay. Well, if we look at this, our numerators of each of our terms, these are odd numbers. So the numerator is always an odd number. It's the sequence of odd numbers. The denominator is the sequence of even numbers. So an equals Well, what did I just say the sequence of odd numbers equals? What's the function that gives us the sequence of odd numbers? 2n minus 1. And what was the formula? What was the function that gives us the sequence of even numbers? 2n. That's it. We can always check this. If we plug in 1, a1, we would get 2 minus 1, which is 1, over 2 times 1, which is 2. 1 over 2, that is the first term. You can test it for all the others that were given there. Part B, negative 2, 4, negative 8, 16, negative 32, and so on. Well, I'm going to approach this with 2 steps. First, I'm going to ignore the negative, positive for now. Instead, looking at these absolute values, looking at these numbers, we have 2, 4, 8, 16, 32, what's happening each time? Okay. We are multiplying by 2. In other words, we're raising 2 to some power. What power of 2 are we starting with? The first power. So an, we should have 2 to the nth power involved. The first term is 2 to the first, the second term is 2 to the second, the third term is 2 to the third, and so on. Okay. Again, we're multiplying by 2. That's just an exponent. An exponent is repeated multiplication. Now, if we're talking about this alternating sign, we have negative, positive, negative, positive, negative, positive. What gives us that pattern? Well, we have some multiple of negative 1 involved, okay? Right? If I multiply 2 to the nth power by negative 1, I would get a negative number. Okay. But it's not always negative. So what would turn negative 1 into positive 1? Well, if I multiply it by itself. How many times? An even number of times. And if I multiply negative 1 by itself an odd number of times, I should get a negative. Does this give us the correct sequence? If I plug in 1, negative 1 to the first power is negative 1. If I plug in 2, negative 1 squared is positive. To the third, negative. To the fourth, positive. To the fifth, negative, and so on. In general, if you see a sequence and it's alternating sign like this right here, negative 1 to the nth power, is what gives us that alternating sign. Okay, so just good trick to remember. Not really a trick, just something to remember when we're making these nth term formulas. Okay, negative 1 to the nth power is what creates an alternating sequence. All right, so that's finding what we call an explicit formula for the nth term of a sequence. In other words, if I ask you, what's the 937th term of the sequence? If you have the nth term formula, you can just plug in that term number and it will give you the term value. The very last thing I want to talk about, the other kind of sequence that we'll discuss, okay? The other way of writing the function for a sequence, is what's known as a recursive sequence. Recursive sequence. This means that instead of having an explicit formula that gives us any term value that we want, a recursive sequence is defined in terms of the previous term. For example, example 3. an equals 3 times a, and then this subscript. So this way of describing our list, of ordering our numbers, n minus 1 plus 2. Okay. This kind of notation becomes very, very common the higher you get in math. So it's the first time you're seeing this, most likely. That's okay. So let's talk about what this means. The nth term, we know what that means. It's the same as plugging in some number n. That's the nth term of our sequence. The n minus 1 term, then, is whatever that term is, but the one before it. So if an is the third term, okay, if n equals 3, then an minus 1 is the second term. 3 minus 1 is 2. That would be a2. Okay. This way of describing this function is a recursive definition. Okay. Recursive, again, just means that we're defining the nth term in terms of the numbers that came before it. So if I ask you what's the 937th term, you can't just plug in 937 here because it depends on what the 936th term value was. Okay. That's the difference between an explicit formula and a recursive formula. Okay. Now, for example 3, they're telling us that a1 equals 1. That's important. We need some term to get started. And they're asking us to find the first 5 terms. So we need a2, a3, a4, and a5. Well, a2, that's going to be 3 times a. Now n is 2, so let's write it out here. 2 minus 1 plus 2. 3 times 2 minus 1 is 1, so this just becomes a, and then our subscript is 1. So this is just our a1 value. And what is a1 equal to? It's 1. 3 times 3 is 9. And we would continue this way. a3 is a3 minus 1 plus 2 times 3. a3 minus 1, that's just a2. And what is a2? 9. 9 plus 2 is 11, times 3 is 33. So you see, a recursive sequence depends on the terms that came before it. So we have to go through each term step by step to get to the next. It's not quite as helpful as an explicit nth term formula, but depending on the situation, there might not be an explicit formula that will give us the term in the sequence. Okay, the example I list here, there's no known formula that will explicitly give the nth term in the sequence of prime numbers. Prime numbers are a pretty important thing that we study in math, but we can't define them explicitly. So sometimes we do have to turn to these recursive definitions. And I'll just skip the calculations for these last two, but it would be very similar. a4 depends on the value of a3, a5 depends on the value of a4. One last example I'd like to do today. Example 4. Find the first 11 terms of the recursively defined sequence if f1 equals 1 and f2 equals 1. fn equals fn minus 1 plus fn minus 2. All right, so what does this mean? This means that the nth term depends on the term that came before it and the term that came to before it. So the third term is going to be 3 minus 1 is 2. 3 minus 2 is 1. The sum of the first and the second terms, 1 plus 1, which is 2. The fourth term is going to be the third term plus the second term. The fifth term is the fourth term plus the third term. So that's what this weird notation means. Okay. I think it's more helpful in this case just to write out our numbers. We don't need to write this formula out every single time, especially since we're doing the first 11 terms. So the next term is going to be 2 plus 1, which is 3. And the next term is going to be 3 plus 2, which is 5. And then 5 plus 3, which is 8. And so on. And we want the first 11 terms. Okay. There we go. This sequence has a special name actually, where each term is the sum of the two terms that came before it. This is known as the Fibonacci sequence. Okay, so those of you who like math, you're interested in it, perhaps you've heard of this before. If you haven't, I encourage you to look this up. Fibonacci sequence is incredibly famous, okay, named of course for mathematician by the name of Fibonacci. All right, so just to recap one more time, I know it's a little longer today, but this is either completely new for you or just there's a lot to remember here. Sequences is just an ordered list of numbers. Okay. We have two ways of describing a sequence. First, we have an explicit formula for the nth term that will give us a specific term in our sequence. The other way of defining a sequence is called a recursive definition. Okay. Recursive means that a given term depends on the term that came before it in order to find its value. So sequence, it's a function, it's an ordered list of numbers. Two ways of describing a sequence, of defining it, either explicitly with an nth term formula or recursively with this recursive definition. We will look at the two main types of sequences. So these are two ways of defining a sequence. Tomorrow we'll look at the two main types of sequences. We'll do that tomorrow and Thursday. You do have that exit ticket due by midnight tonight, and I encourage you to get started with the 8.1 independent practice, okay? Please stay on top of things. This unit won't be terrible if you follow along and you keep up with your work. Otherwise, I make no promises. Join our Google Meet if you have questions. Have a great day. All right, well, let me know if you need anything. Join our Google Meet later today. Please, 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 please do your work. Stay safe. We're here for you.